Imperfections in solids. Usually, a solid consists of an aggregate of large number of small crystals. These small crystals have defects in them. This happens when crystallization process occurs at fast or moderate rates. Single crystals are formed when the process of crystallization occurs at extremely slow rates. The deviation from the perfect periodic arrangement of constituent particles of solids is called imperfections in crystals. These imperfections or defects in crystals are of two types. They are point defects and line defects. Point defect arises due to the irregularity in the arrangement of particles around a point or an atom in a crystalline substance. Line defect arises due to the irregularity in the arrangement of particles in the entire row of crystal lattice. Let me discuss point defects in detail. Point defects can be classified into three types. They are stoichiometric defects, impurity defects, and non-stoichiometric defects. Stoichiometric defects in detail. Stoichiometric defects are the point defects that do not disturb the stoichiometry of the solid. They are also called intrinsic or thermodynamic defects. Basically, these are of two types: vacancy defects and interstitial defects. Stoichiometric defects can be discussed at two different levels. Number 1. Stoichiometric defects in non-ionic solids. Number 2. Stoichiometric defects in ionic solids. Let us discuss stoichiometric defects in non-ionic solids. Vacancy defects. When some of the lattice sites are vacant, the crystal is said to have vacancy defects. This results in decrease in density of the substance. This defect can also develop when a substance is heated. Interstitial defect. When some constituent particles, atoms or molecules occupy an interstitial site, the crystal is said to have interstitial defects. This defect increases the density of the substance. Let us discuss stoichiometric defects in ionic solids. Rather than simple vacancy or interstitial defects, ionic solids show these defects as Frenkel and Schottky defects. Frenkel defects. This defect is shown by ionic solids. The smaller ion, usually cation, is dislocated from its normal site to an interstitial site. It creates a vacancy defect at its original site and an interstitial defect at its new location. Frenkel defect is also called dislocation defect. It does not change the density of the solid. Frenkel defect is shown by ionic substances in which there is a large difference in the size of ions. For example, zinc sulfide, silver chloride, silver bromide, and silver iodide due to the small size of Zn2 plus and Ag plus ions. Schottky defects. It is basically a vacancy defect in ionic solids. In this defect, a cation is missing from its normal site. In order to maintain the electrical neutrality, an anion is also missing from its normal side. That means, in order to maintain electrical neutrality, the number of missing cations and anions are equal. Schottky defect decreases the density of the substance. Schottky defect is shown by ionic substances in which the cation and anions are of almost similar size. For example, sodium chloride, potassium chloride, cesium chloride, and silver bromide. It may be noted that silver bromide shows both Frenkel as well as Schottky defects.